mentally math.
Let's get mental.
That was a good one.
The other one's probably saying what's up, G. For D, we should have or have?
Have, double. Use the have and double method.
Okay.
Yeah.
What's the square root of 1?
What do you think
One.
well, what do you multiply by 1 to get?
1.
Yeah. What's 1 times 1?
1.
1. Someone was arguing this morning that technically -1 times -1 could also be 1, but I think for the purposes of this, we would just say 1, which, by the way, does relate to today's lesson. I'll give you a moment to get out ahead of me.
When we were watching your video on the other 2 days,
You sped it up double time?
we put it at 3.
Okay.
We put it at
You
half.
sped it up, yeah. Sounds like it was funny.
Yeah, it was.
You're like, let's get mental. I kept going. Like,
Okay, alright. Good talk, but why don't you focus on what you're doing? Okay, so I'm sure you're at least a couple in, right?
Yes.
Good. Okay, I will assume you're at least a little bit ahead. Alright, so I could think of 50 cents plus 75 cents is $1.25. Then looking at that, square root of 1. So 1 minus 1/4 would be 3/4. Then 1 plus 35 is 36 divided by 4 is 9. Have and double. So I could look at this as 6 times 5 equals 30. That's what they mean by have and double. Half one, double the other, and oh my goodness, it's so simple. Then, so they seem to really like decimeters this week. I guess they just want, since they're not really used a lot, they just want to kind of solidify it in your brains of what a decimeter is. Yo.
Actually, my mom taught me a new trick on how to do these, and it's kind of a lot easier than trying to remember and memorize, trying to memorize how to convert them.
Oh.
And it's basically a few, so if you're converting from bigger to small, that's going to be multiplication. If you're converting from small to big, then you divide.
Sure.
And you see how many places. So in this case, it's going to be by 10, and then if you multiply by 10, you get 200 centimeters.
Right. Or I just like to say boingy, but you know. Yeah.
Yesterday, the estimation came when you were here.
I know, funny, right? Okay, anyway, moving forward as we need to. I know that there are 10 centimeters in 1 decimeter because there are 10 decimeters in 1 meter. So I can take my decimal and move it over by 1. Boingy. So it'd be 200 centimeters, also known as 2 meters. Then 1/3 of 24 is 8. Then the circle of diameter is 20 millimeters. This is mentally mathable. So I can say 6 to 8 and then multiply by 10. So right there. Yeah, the other day we just did times pi because I wasn't really sure how 16 would work out as mental math specifically. So that was a good escape route out of that, and probably what they were getting at to do. But in most cases, yeah, you should. Now, if this had been 21 millimeters instead of 20 millimeters, then what would have been a better way to do this? Yeah.
I guess fractions would have worked.
Yeah, the 22 sevenths, and then I could have done some cross-canceling goodness and made it really simple. Okay, so then find the perimeter area of a rectangle. So perimeter would be 4 plus 3 is 7 meters. And the area would be 2 times 1.5, which would be 3 square meters. All right. Okay, so today, well, their phrase for this is algebraic addition.
Yeah.
This actually works with one of my favorite catchphrases. Is, you know what, kids? 2 wrongs don't make a right, but 2 negatives do make a positive. Okay, and what I mean here is, and this kind of only works for multiplication. But technically, in a sense, we are doing multiplication. Oh goodness, what wizardry is this? Simplify. 3 minus -2. Yeah?
So 2 negative signs equals a positive sign?
Yes, and
one positive sign and a negative sign equals a negative sign?
yes, and think of it as kind of a review of multiplying. So if you multiply 2 negative numbers, you convert it over to a positive number, and if you multiply a negative number times a positive number, then you will have a negative number. Now, how this applies to this, and the way the Saxon book likes to help you figure out how to simplify this is by adding your own symbols of inclusion, adding brackets to it to kind of give you a sense of what you are supposed to do first to simplify it, and then work with what you've got. So in this case, what we've got to figure out is that right there, right? So we can put some brackets around here to say, let's do this first. And then, now here's a good way to look at this. So like we were saying with multiplying, what this is technically saying is -1 times -2. Just the -1 is sort of imaginary. Does that make sense?
I thought he was trying to say -3 minus -2.
It is, but your first step in simplification is figuring out a way to simplify that part. So by doing this part off first, you can think of it as, like I said, as -1 times -2, which would be, what would that be? 2. Positive 2. Okay, and so then what you would end up with, let me put this over here, is -3 plus 2.
5.
Oh no, it is not 5. Let us take a Saxon number line and see what's going on here.
Oh, -2.
Yeah. That is what the answer will be.
What if the air conditioner sound like it's chirping?
You know, I don't really need to have that on. It's loud. Why don't I turn it off? And it's not the air conditioner. Oh, that's the heater.
Oh.
And that's not helpful to our math discussion to change the subject to that. Okay, so is this about this problem?
Yes.
Okay.
How did you get -1? I thought that it was 2. Oh wait.
Because there's a negative sign. I mean, if this is a little confusing, you could just think in terms of 2 negatives. Whoops. You could just think, okay, I've got 2 negative signs slapped against each other there, so I needed to convert that to being a positive number. But I was trying to just sort of illustrate that technically what's going on there is that's kind of an imaginary -1 times -2. But if that makes it more confusing, then make it more simplified, then you can just think in terms of I've got 2 negatives, I need to convert that to a positive. So
-1 plus -1.
So we're going to start out by starting at 0, then going 3 value of -3. So -3 means you're going to the left. And then once you get there, this states you're going back. A little too far. States you're going back a value of +2, or 2 to the right, which would put you down at -1. So that's a way you could look at it. Or you could just look at of combine. You could use the commutative property to do that, which that makes it seem a little bit more obvious that your answer would be -1, right? That other way. So you could look at this a couple of ways, but the answer is definitely not any version of 5. Okay. All right, so let's see if you can take the bracket challenge. Please copy down this equation and then figure out where your Saxon brackets should go in order to simplify this to something that makes a little more sense. So I'm gonna give you a minute to copy down and then try to figure out where brackets could go to in the way that we just showed to kind of simplify what's going on here. Because right now we've got -2 -5 minus +6, huh? Oh, well, just copy down the equation though, then, and we'll see where I go with that. So, yeah? Okay, grab a buddy and go get it. Or maybe you might want to wait till the lesson's over. Anyway, so we're talking about math. Now, they do this, I think, for clarity, but did we really need that there? No. But because we assume if there's nothing designating it that it's a positive number. Just saying. Okay, so that should have given you enough time to at least copy down the equation. So where we have got our wonky stuff here, you could say we could put some symbols of inclusion there and some symbols of inclusion there. And so I could think of this as an imaginary -1 times 2 will just get me a +2. And then we could just keep our -5. And then we can look at this and say, well, this is kind of like -1 times +6. Which would be like what? Which would give me what? What would be if this was, think of this as a -1 times 6 would be -6. Yes. Okay, and then a few different ways you could do this. We can see what this would look like on a Saxon number line. Okay, and I think my 0 here. Okay, let's go 1, 2, 3. Okay. So now just to say, you could just go across and go, okay, if I combine a value of 2 and -5, that will actually get me a -3. And then a -3 combined with the value of -6 would get me a -9. If that seems weird and like, how does that work? Let's see it in action.
Quick question, Mr. Crabtree.
Yep.
So, subtracting a negative number from a negative number would also result in a negative number?
Yes, because you are... So my whole two negatives make a positive thing absolutely does not apply to anything other than multiplication. What you're doing at that point is you're combining the value of -5 and -6. So the combined value of those is -11.
So if both numbers are negative and you're subtracting them, you just combine the values?
Yes.
Okay.
Yes. So if we're looking at what's going on our Saxon number line here, then so this would get us to +2. But then now I'm going to go back by a value of -5. Which will get me to -3. And then -6 is going back another jump to the left.
Do we have to use number lines?
No, I'm just trying to illustrate this for you.
Okay, thank you.
Just to try to give you an idea what's happening with the numbers if just looking at the equation like makes you a little bit bamboozled. Okay, so yeah, I'm just trying to just give you a sense of what's going on with the numbers. You don't have to do the Saxon number line. Okay.
Doing them for fun.
Yeah, I think they're fun myself, personally.
Satisfying when you just go.
Okay, so speaking of combining negative values. Alright, see if you can figure this one out. And then check yourself with me. So, go for it! What's this gonna look like when you're done? Should only take you a minute. This one's really simple.
It's gonna look like
Well, I'm not asking you to blurt it.
negative sign.
So, But please, let's not blurt the answer. Did you finish it already on your paper? Okay. I'm gonna let people finish it on their paper first, and then just check yourself with me. Okay, so just going with the way Saxon's doing it, I'm gonna bracket this off, and this was okay. So then this will end up being a value of -1 1/2. So we're kind of just looking at as that, and as we said before, that if we're combining the value of two negative numbers, we are essentially adding the value of them together, but then we're going to slap a negative sign on it. Ta-da! And we're done. Not too tricky, right? Okay.